Hello everyone, welcome back to my channel. My name is Chinmaya S. Shetty from Sri Venkateswara College of Engineering from the branch of Information Science and Engineering. In this video, I am going to tell about asymptotic notation from the subject of analysis and the design of algorithm. Asymptotic notation. It is a way of describing the limiting behavior of a function as its input size approaches infinity. It is commonly used in computer science and mathematics to analyze the efficiency and performance of algorithms. It provides a high level understanding of how an algorithm scales with input size. Big O notation. It denotes as a big O of f of n represents the upper bound on the growth rate of a function. It describes the worst case scenario of an algorithm in terms of the time complexity. For example, an algorithm with big O of n power 2 time complexity means that the algorithm's running time grows quadratically with input size. Omega notation. It denotes as omega of f of n represents the lower bound on the growth rate of a function. It describes the best case scenario of an algorithm in terms of time complexity. For example, an algorithm with omega of n time complexity means that the algorithm's running time grows linearly with input size. Theta notation. It is denoted as theta of f of n represents both the upper and the lower bounds on the growth rate of a function. It describes the tightest possible bound on the algorithm's time complexity. For example, an algorithm with a big notation of n time complexity means that the algorithm's running time grows linearly with input size and is neither faster nor slower. Comparing asymptotic notations. Big O notation is used to describe the worst case scenario, and omega notation is used to describe the best case scenario, and theta notation is used to describe the average case scenario. Common examples for of asymptotic notations are big O of 1 represents a constant time complexity where the algorithm's running time does not depend on the input size. Big O of log of n represents a logarithmic time complexity commonly found in binary search algorithms. Big O of n represents a linear time complexity where the algorithm's running time grows linearly with the input size. Uh, Another examples of asymptotic notations are big O of n log n represents linear-rhythmic time complexity often found in efficient sorting algorithms like merge sort and quick sort. Big O of n power 2 represents quadratic time complexity where the algorithm's running time grows quadratically with the input size. Big O of 2 power n represents the exponential time complexity where the algorithm's running time doubles with each additional input element. Benefits of using asymptotic notations. It provides a standardized way to compare and analyze the efficiency of algorithms. They abstract away constant factors and lower order terms, focusing on dominant factor that determines an algorithm's efficiency. It helps in making informed decisions about algorithm selection and optimization. Limitations of asymptotic notations. It may not always accurately reflect the actual performance of an algorithm in practice. They do not account for variations in hardware compiler optimizations and specific input data characteristics. It is important to complement asymptotic analysis with empirical testing to validate Theoretical predictions. Practical applications of asymptotic notations. They are widely used in designing and analyzing algorithms in computer science and software engineering. They help in predicting the scalability and efficiency of algorithms for large input size. It guides algorithm designers in making trade-offs between time complexity and space complexity. Understanding growth rates with asymptotic notations. It provides a clear understanding how algorithms scale with input size. They help in identifying the most significant factors that impact an algorithm's performance. By analyzing growth rates, developers can optimize algorithms for better efficiency and performance. Real-world examples of asymptotic notations. In web development, analyzing the time complexity of algorithms can optimize website loading speeds. In machine learning, understanding the computational complexity of algorithms is crucial for training models on large data sets. In database management, efficient query processing release on algorithms with low time complexity. Best practices for analyzing algorithms with asymptotic notations. Start by determining the input size and key operations performed by the algorithm. Identify the dominant factor that influences the algorithm's time complexity. Use the appropriate asymptotic notations like big O, omega, or theta to describe the algorithm's efficiency. Challenges in applying asymptotic notations. Analyzing recursive algorithms can be complex due to their self-referential nature. Handling algorithms with very varying time complexities at different stages poses challenges in asymptotic analysis. Interpreting the implications of different asymptotic notations requires a deep understanding of algorithmic complexity. Advanced concepts in asymptotic notations. It can be extended to describe space complexity in addition to time complexity. Multivariate asymptotic analysis considered the growth rates of multiple variables in algorithmic analysis. It plays a crucial role in complexity theory and the study of computational complexity classes. Future trends in asymptotic notations. With the rise of parallel and distributed computing, there is a growing need for analyzing algorithms with a parallel complexity. It may evolve to accommodate the complexities of modern computing architectures and algorithms. Machine learning algorithms can benefit from advanced asymptotic analysis to optimize training process and model inference. Resources for learning asymptotic notations. Online courses and tutorials on algorithm analysis often cover asymptotic notations in depth. Textbooks on algorithms and data structures provide comprehensive explanations and examples of asymptotic notations and analysis. Academic papers and research articles in computer science delve into advanced topics in asymptotic notations and algorithm complexity. Conclusion. Asymptotic notations are a powerful tool for analyzing and comparing the efficiency of algorithms. They provide a standardized framework for understanding algorithmic complexity and scalability. By mastering asymptotic notations, developers can design and optimize algorithms for optimal performance. Thank you.